So here we're going to use properties of logarithms in order to write them in terms of two logarithms, of x and of y. So the first question here, you can use the product rule that we have. So this is the same as writing log x plus log of y to the fourth, because if you multiply inside of a logarithm, it becomes addition. And if you want, you could even write this as log x plus 4 log y, because the exponent in the top can become a scale in the front, like that. Similar for b, this is same as writing, if you divide, you subtract. So this is log minus y. And again, this actually can be written as, you can apply the product rule to that first term, which would be log 3 plus log x squared minus log y. And again, the 2 in the x squared can become a multiplier in front. So this is 2 log x minus log y. So that's fully expanded in a sense. Part C, this cannot be simplified. It's not that it doesn't exist, it just, you can't do anything with it. Specifically, what this is absolutely not is log of x divided by y to the fourth. This is a common mistake. That's not true. You can only use the quotient to subtraction rule if you're actually dividing inside, like we are for part B. Part E, you can write this as, well, you're dividing. So you can actually write this as log of 1 minus log of x cubed y. But for any base, the logarithm of 1 is 0. So this is the same as writing this, x cubed y. And now this is, you can use the product rule. So this is log of x cubed plus log of y. And notice I've kept the negative sign out front. You can't, because now that we're adding, we would have to, fully factor that out. And so this is negative 3 log x minus log y. You can put the negative 3 in front and it just becomes negative. And the negative sign stays here because it was being distributed to both. Okay. Now we want to go the other way. We want to write an expression as one logarithm given multiple ones. So the first step, the only first step here, is to note that you can write this as log 9 of 5 squared. So when for the last example, we put the power out in the front, we can go the other way. If you had a constant in the front, it can become the power. And so here that means that the 2 is the power of the 5. You have this. And now that you do not have a coefficient here, like originally we had 2 and we had to deal with that, but now that that's gone, we can write this as log base 9 of 2 over 5 squared. So log 9 2 over 25, if you want to write it in that way. But you had to get rid of the 2 first, because you can only apply this difference quotient rule thing if you don't have coefficients in front. So we had to do that first. Okay. So for part C, we can write this as log x, and this is actually 1/2 log y, and this is actually 1/3 log z. So this is the same as writing log of y to the 1/2 plus log z to the 1/3. So this is just applying. So now we've gotten rid of the coefficients. Now we can apply the product addition rule. So this is log x times y to the 1/2 times z to the 1/3, like that. My hesitation was on B. I don't know if this can be done because you have different bases. So you could write this as this, but that can't be simplified anymore because you have different bases. And you could convert them into a common base, but I don't know if that was if that was the goal here. So you could write this as log of x squared divided by log of 3, where this is now base 10, right? There's no subscript. And then you can write this as y to the 12th over log of 5. But I don't think that was the point here. I think the point was to say that this cannot really be simplified much more, because even this is not really helpful. So I'm going to erase that. All right, and then D is very similar to part A. All right, solving exponential equation. This is more important. So let's look at, I guess A first. This one's pretty easy though. You just use the definition of the logarithm here. So this just says by definition that the log base 4 of 15 is the exponent, so z. And that's, if you want an approximation for this, you just do that on your calculator. Part B, you want to isolate this 3 to the x term. So this is 3 to the x equals 35 over 5, and that's 7. So we have 3 to the x equals 7. So again, using the definition of the logarithm, this means that log base 3 of 7 is x. Okay. Part C, this is where it gets a little bit more complicated, because now you have two different bases and different exponents. So what I would advise that you do is that you write this equation, although you don't have to, as 2 to the x. Well, no, let's not start that way. So you would take the logarithm of both sides. It doesn't matter what base. It literally could be anything, but either 10 or e, right, ln, would be better. So you can write like this, and then you can bring the x out. So this is x times log of 6 is equal to the whole exponent, x minus 3 log 2. And so now you can write you can expand the left side, or the right side. You just distribute. So x log 2, which is just a number, minus 3 log 2, which is again just a number. And now you can move this to the other side. X log 6 minus x log 2 is negative 3 log 2. Factor out x log 6 minus log 2, negative 3 log 2. So I just factored out. We have an x there and an x there. And then you can divide by that term, the log 6 minus log 2. So this is negative 3 log 2 divided by log 6 minus log 2. And that would be your whole answer. You could simplify this a little bit if you want, but that is what you would get. All right, and then I'll do part F, but in a slightly different way. But you don't have to. So you could start this by doing what I did. You would do the log of both sides, and then expand out. Another method, which is very similar, that you can use here is to rearrange this. So if you divide by 2 to the x, then you have 60 3 to the x over 2 to the x equals 25. So I divided by this term on both sides. And now you can write this, you can then divide by 60. So this is 3 to the power of x over 2 to the x equals 25 over 60. And that both sides are divisible by 5. So this is 5 over 12. So now what you can do is you can take the logarithm of both sides. You'd have log of 3 halves, or 3 to the x over 2 to the x is now equal to the logarithm of any base, but I'm just doing base 10, 5/12. But this is the logarithm of 3 halves to the power of x, right? That's just using exponent rules, because if you have a power in the numerator and the denominator, it's the same as doing the whole fraction to that power. And then on the right, you still have 5/12. But now your x can come out. So this is x times the logarithm of 3 halves equals the logarithm of 5/12. You can then divide by the log of 3 halves, and you get x is log 5 halves over log 3 halves. And this is the answer. The step that you would avoid by doing this method, kind of like by like isolating the powers here, is that you don't have to factor out, you don't have to distribute and then factor the x like we did here. But that's not required. Like you can do either method. Either way will work. This might be a little bit easier to visualize. It's fewer computations, but you would have to think about kind of like this conversion here. But either way is fine.